Okay, let's talk about vectors. And this time we're going to go over a particular aspect of a vector. A vector is a quantity that has both, first off, magnitude, which I'm going to focus on this in this video, and secondly, direction. Now let's talk about this idea of magnitude. In a different video we'll talk about direction. Now you should have this written down already. If not, you should write it down now. But vector magnitude. First of all, magnitude, another word for that would be value. We often represent a vector as an arrow. So why do we represent a vector as an arrow? Well, because an arrow has both direction that it points, and the length of that arrow is correspondent to magnitude, or the value of the vector. So if I put two vectors parallel to each other, but one obviously longer than another, then this vector here that's longer, that I just check mark, is the vector that has a bigger magnitude or a bigger value. So let's say these vectors represent a displacement. The first vector might be a 3-meter displacement, where the other vector might be a 5-meter displacement. The longer the vector, the bigger the magnitude. Now, how do you go about finding magnitude for a vector? Well, there's two ways to determine magnitude for a vector. First of all, you could do it with a scale diagram. And we're going to cover a scale diagram a little bit more in class. But basically, a scale diagram, you would just use typically something like a ruler to measure how long the vector is, and by knowing the scale that's in the diagram, you could figure out what the magnitude of that vector is. But there's another way, and a more common way that we often employ to determine the magnitude of a vector. Often vectors are formed by adding together two other vectors. So if this vector was 3 meters, and I wanted to add to that a vector that was perpendicular to that, in this direction of 4 meters, how would I do that? Well, this is how you do it. You place the two vectors tip to tail, where the tip of the vector is this part right here, and the tail of a vector is that part right there. So you can see over here on the right, let me box it in here, those two vectors have been placed tip to tail. Now how do you figure out what's produced by that vector? What's the resulting vector that's formed when you add them together? Well, you connect where you start it to where you end it. And we start it down here, and we end it up there. And so we connect that, and that green line is the result vector, or the resultant vector of adding the other two together, the 3 meter and the 4 meter together. Now once you have that, how do you determine the magnitude of that new resultant vector? Well, in order to determine that magnitude, we're going to use Pythagorean. Now we've all seen or heard of the Pythagorean theorem before. It looks something like this. C squared equals a squared plus b squared, where c is known as the hypotenuse, and a and b are two other sides to a right triangle. Now we happen to have a right triangle here, at least it was intended to be a right triangle, so we can use Pythagorean theorem. What's the c side? Well, that's this side over here because it's opposite the right triangle. That's the hypotenuse. So if I want to figure out what this c side is, the magnitude of it, I would say that c squared equals the a side, which is 3 meters, square that up, plus the b side, which is 4 meters, square that up. And what do we get? Well, we get that c squared equals 9 plus 16, or 25. Well, if c squared equals 25, what's c equal? Take the square root of both sides and we get 5, and that would be 5 meters. So you can see another way to go after finding the magnitude is to use components of the vector, and this side right here and this side right here is also known as the x component of that green vector, and this is known as the y component of that vector. And by employing Pythagorean theorem, you're able to find the magnitude of that vector. Hope this review was helpful for you. That's all for now.